Let's take a look at absolute value functions. We're going to graph them and then write them as a piecewise function. So in this absolute value function, I can tell that it's going to the right 1 and up 3. So from the parent function that would start at the origin, I went right 1 and I need to go up 3. And then it had no negative, so it didn't reflect, and it has no vertical stretch or shrink. So we can just draw a line going up 1 over 1 in each direction and up 1 to the left 1 in each direction. And we could also have created a table of values if we wanted to pick out some points. So that would also have helped. But I'm just trying to show you kind of quickly how to graph it and then how to write the piecewise function. So now to write our piecewise function, we're going to write it as this positive line, this negative line, and then the point in the middle is a separate piece. So if we start with this positive line, it looks like our y-intercept would have been at 2, and it has a slope of 1. So we put x plus 2 as the equation of that line. But it's only for values that are greater than 1. So we're going to put if x is greater than 1. And then the point in the middle, we can say y equals 3 at x equals 1. So we would say f of x is the same thing as y equals. So we put y equals 3 if x equals 1 is the point right there in the middle. And then this line is the one that has a slope of negative 1. And that looks like our y-intercept is right there at 4. So we have negative x plus 4 for the equation. And that's if x is less than 1. So it's for all the values where x is less than 1. All right, so let's look at this one. This one has a left shift 5 units, and it's going to reflect over the x-axis. So using our transformations, we can quickly put this on our graph. So it usually starts in the middle at the 0, 0 for our parent function, but we're going to shift it to the left 5. So 1, 2, 3, 4, 5. And then it reflects over the x-axis, so it just goes down 1 box at a time in each direction. And then we're going to write out our 3 functions that would make this a piecewise function. And again, you could have used a table of values if it helps, or you could use your calculator to help you get the graph. So let's put the positive line, which has a slope of positive 1, and if we kept on going, it looks like it would have a y-intercept of 1, 2, 3, 4, 5. So it has a slope of 1 and a y-intercept of 5. And that is for all the values of x that are less than negative 5. So that's if x is less than negative 5. This point right here in the middle is y equals 0, where x equals negative 5. So y equals 0 if x equals negative 5. And then this line has a slope of negative 1, and it would touch at negative 1, 2, 3, 4, 5. So a slope of negative 1 and a y-intercept of negative 5 would be negative x minus 5. And that's if x is greater than negative 5. Okay, let's do one more. So this absolute value function just simply moves up 4 units, and other than that, it'll look like our parent function. So up 1, 2, 3, 4, and then it just goes 1 box at a time in either direction. And then we can write our equations. So we have a y-intercept of 4, but we have one with a positive slope and one with a negative slope of 1. So that'll be x plus 4 and negative x plus 4. And then right there at that point, we would say that y equals 4 and x equals 0. And then if x is greater than 0, it's this positive line. And if x is less than 0, it would be this line. So we put x is less than 0. Okay, so that's it for absolute value functions.